Welcome to HOS Technologies. Here we are demonstrating automatic irrigation system along with temperature monitoring and alerting through buzzer and visual display on 16:2 LCD display. So here the main input sensors are LM35 for temperature monitoring purpose and soil moisture sensor. So these two probes are give the inputs, analog input to this LM358 comparator IC board, and it will give the digital outputs to the Arduino UNO board. And LM35 is a analog output. So LM35 interface at A0 pin and soil moisture sensor interface at A1 pin. So based on these two inputs, Arduino UNO microcontroller will make the decision of to control this relay along with the buzzer, and the respective data of the temperature will be displayed on the LCD in temperature in degrees centigrades, and a moisture sensor dry or wet. So these parameters will be displayed on the LCD. And coming to this LCD interface at 2 to 7, pin number 2 to pin number 7, and the relay interface at 12th pin, buzzer interface at 13th pin of the Arduino UNO board. And this is the breadboard kind of connections, means we are going to distribute the 5 volts power supply to this modules like LCD, relay, buzzer, moisture sensor and temperature sensor. So these modules are needed 5 volts power supply. So now we are going to provide the 5 volts directly from this adapter, and and this 5 volts will be distributed parallelly throughout this board tracks. And from here we are going to distribute the 5 volts power supply to the input and output modules. So as we discussed, the input modules are soil moisture sensor and LM35 temperature sensor, and output modules are relay and a buzzer and a display purpose LCD display 16:2. So here whenever the soil moisture sensor give the input of dry, and then microcontroller will display the soil moisture sensor, moisture level is dry, and that motor will getting switched on with the help of this relay. And coming to this relay circuitry, so here we are using electromagnetic relay. It's a 5 volts operated. Here the LED indication also indicate the relay status, and this diode is used to neutralize the back EMF generated from this relay, because the relay is made of inductor. So whenever the inductor getting switched off, the back EMF will be generated and it will neutralized by this diode connected in reverse bias. Coming to this buzzer, we are going to use a piezo buzzer. So this piezo buzzer need a 5 volts power supply with 100 milliamps of minimum current, and microcontroller will affordable up to 20 milliamps only. And in order to provide the maximum current, we are using the transistor as a switch. Means here we are going to on this transistor, and the transistor will on the buzzer. In the same way, we are going to on the relay, and this relay will going to on this motor. So in this manner, based on the inputs, controller will control the output modules. For temperature high increment, so we set the temperature limit of 50 degrees. Whenever it crosses, buzzer will be on. So let us see the demonstration. So we need to provide the two power supply, one for the motor and another for the kit. So after switching on this kit, so after 5 to 6 seconds, there will be a welcome message on the LCD display, right? So the welcome message will be displayed, and it is showing that moisture level is wet and temperature is 33 degrees centigrades. Okay, and whenever the moisture level is dry, on the next second only the relay getting switched on and buzzer will be indicated. So we can see the moisture level is dry. Whenever it kept back, means the water level is sufficient, then automatically it will be off along with the buzzer and the motor. And I'm going to increase the temperature. So you can see the temperature is getting increasing. So now I am going to increase the temperature here. So whenever the temperature crosses 50 degrees centigrade, then the buzzer will be indicated along with LED indication on the UNO board. And when it is settled down, automatically the buzzer will be off. Right. Thank you.